This is going on page 28 when we are done. We are still talking about polynomials. Hang on, I got to get my tea. I don't know why I take it back to my desk. Still talking about polynomials. And we are talking about the end behavior today, right? We talked about some middle behavior. Middle behavior is not really a thing, but it's kind of what I call it. Your points of inflection, your maxes and mins, they all kind of happen like in the middle. We're talking about the ends. And for polynomials, our domain is negative infinity to infinity for all of them. So we're talking about the ends, we're talking about what happens at the infinities, okay? So the key word in end behavior is end behavior. So the end behavior of a function describes how a function behaves as it moves infinitely right and left, okay? So this is the one thing we do where we move to the left on the graph. So everything else we do, it's as x gets bigger, as we go from left to right on the graph, what's happening to y or whatever. But when you're talking about end behavior, I'm going to talk about what happens when I go to infinity and what happens when I go to negative infinity. So I'm like pushing out to the sides, all right? We're not writing intervals that way, so our intervals will still always be left to right and least to greatest or bottom to top, but you're going to look at the graph a little bit differently. So in other words, the end behavior is what happens to the values of y as x increases or decreases without bound. Without bound is another way to say the infinities. There's no boundaries. I can keep going forever. Okay, so without bound means we're heading to positive or negative infinity. Okay, all that makes sense so far? Good? All right. So then we're going to look at limit notation. So it's not just about understanding where we're going with this, but how to write it. And limit notation is very specific. It's also pretty simple. But if you don't have it exactly right, you're not getting credit for it on the exam. Okay? They're very particular about it, as they should be. I don't have a problem with that. And so we're going to learn it now. We're going to get it right now. We're going to use it all year, and we're going to be correct about it all year, and it's not that big of a deal. When it's printed, if you look at this, so we're talking about left end behavior, that means I'm heading to negative infinity, right? And so what that is as x values decrease without bound, so what's happening to the y values? That's what we're looking for. So here's what the notation looks like. Little lowercase lim, directly underneath that, there's an x with an arrow pointing to negative infinity. That means the limit as x approaches negative infinity of the function, which is f of x, and then we'd have an answer to that. So when you're asked to write limit statements, you're asked to write it in the notation. We are going to write some words today on the paper, but when you're asked for a limit statement from here on out, you are being asked for something that looks like that. But the way you say it, like the words that would come out of your mouth for this, we're going to write down so anytime you put anything in quotes, it's like how you say the notation. This would be the limit as x approaches negative infinity okay, the limit as x approaches negative infinity of f of x dot dot dot, and then we'd have an answer to that. Okay, the limit as x approaches infinity of f of x. So that's what all that little stuff means. And then this one, of course, would mean positive infinity. So left end behavior, we're heading to the left to negative infinity. Right end behavior, we're headed to the right for positive infinity. Does that much make sense? Yes? Okay. So now let's look at these graphs. So we have this first graph here. He doesn't have a name, so we're going to name him f of x. Okay. And it's the directions that I've just scrolled past. Say, describe the end behavior of the following polynomials verbally and using limit notation. So here's where we're gonna write the words so that we just see another way to say it. But again, these aren't words that you're gonna have to rewrite. Okay, just for you to kind of have an understanding of what's happening. Since we are talking about end behavior, I don't care about this. I'm not even going to look at it. For polynomials, I don't think it confuses you as much as it does with rationals. But like here, I have a point of inflection. I have maximums and minimums. I don't care about any of that right now. I'm looking at this, and that's it, right? So left behavior verbally, I'm heading to the left. So that is as x, right? And this is the words we're going to write. As x decreases without bound. Is that also as x approaches negative infinity? Yes, but that's just a different way to say it. And things can be worded differently for you, and you need to know that they mean the same thing. Or when you read that, you understand how to interpret it, and it doesn't just make your brain hurt. Okay? So as x decreases without bound, f, what is f doing as x decreases? What's the function doing? Increasing. Yes, so as x decreases, the function is increasing without bound, right? So as x decreases without bound, f increases without bound. Okay. That's another way of saying as x approaches negative infinity, f of x approaches infinity. It's just a different way of saying it, means the exact same thing. Okay, but you don't have to worry about restating them. I just want you to have it written out and have thought about it. Now, your left-hand limit notation would look like this. Here's how you write it. Lowercase lim. Then directly under that, technically in smaller font, kind of as a subscript, which is kind of hard to do when handwriting, and that's fine, all right? Because mine's not going to look like a subscript. As x approaches negative infinity, you have to make an honest effort to put it in the right form. I can usually tell when I'm grading if you were doing the right form and like it was like a handwriting issue or things there was too much to write or whatever, or you're just throwing symbols on the paper and hoping that something's right. Okay, it's usually pretty obvious. There's no line here. This is not a fraction. I see that sometimes. Don't do that. Then in front of those two things that are stacked, you put the function, which in this case is f of x. So do you see how you have something stacked and then something in front of it? That's kind of what we're going for here. It's super easy. And so as x approaches negative infinity, f of x is approaching infinity. And that's better than words, right? As much as some of y'all hate notation after all the words we write, I think you're going to become notation fans, right? Can I use notation and not have to write a paragraph? That'd be great, right? Everybody good? Okay, so now look at your picture. In our right hand, so as we go to infinity, so as x increases without bound, f is doing what? Decreasing. Good. So f decreases without bound. Any questions about that? Does that make sense? Okay. So then our limit notation, lowercase lim, directly underneath that, x approaches infinity. Then in front of that, yes, the name of the function, f of x, and that would equal what? Negative infinity. Good. Any questions about that? We all good? Yes? Make sense? Okay, so for right now, the limits that we're talking about, since we're talking about in behavior, our limits are always going to be heading to infinity or negative infinity. And because we're talking about polynomials right now, our answers are always going to be infinity or negative infinity also. We can talk about the limit as x approaches 5. Or we could have a limit answer that is 5. We're just not there yet. Okay, so right now it's just all infinities. You just got to pick the right one. Okay, let's look at this one. Again, it's in behavior. So I'm looking at this. If it helps you to kind of mark that out so you don't try to do weird stuff, that's totally fine. Unless you need the graph for something else in the question, then you might not want to do that. But in this case, it's fine. So our left hand as x decreases without bound. Okay. As x decreases without bound, we're heading to negative infinity. Oh, this guy didn't have a name. Let's name him G. Okay. G is doing what? Increasing without bound. So increases without bound. And then either from the graph or from the statement, either one, I can write my limit statement. Be very careful with how you're writing it. LIM, x approaches negative infinity, and make sure you call him G. Don't make me call you Melissa, right? His name is not F, it is G. This is equal to what? Infinity. Good. Okay. We good with all this? Any questions at this point? We good? You have a question? No. Couldn't tell. Look on your face, I wasn't sure. All right. So then my right in behavior as x increases. So as x increases without bound, G is doing what? Increasing. Good. G increases without bound. Oh, do we get a little? I love it when the light bulbs go off. We get this? Yeah. Okay, good. I thought it was gonna be the same as the other one. Yeah, no, because this one is up down, this one's up up, so that works. All right, then let's write our statement. Limit as x approaches infinity of g of x is equal to what? Infinity. Good. All right. What questions do you have? Anything? Okay, so we took a graph, we came up with our limit statements. So now we have some limit statements. We're going to come up with not the entire graph because we don't have enough information for that. I have no idea what the degree of the function is. I have no idea what, how many zeros it's going to have or whatever, but I can figure out from this the end behavior. So if as the limit as x approaches negative infinity is negative infinity, then the left-hand side has to be pointing down. Would you agree with that? And then as x approaches infinity, if the limit is negative infinity, the right-hand side is also pointing down. Okay? We good on that? All right. So then this one, limit as x approaches negative infinity, which way is the left-hand side pointing? Down. And then the right side would be pointing up. So you actually could tell me something, right? Leading coefficient of this one, would it be positive or negative? Negative, because it's opening down, right? Would the function have an even or odd degree? Even. See how much you already know about it, and we don't know everything, but a lot of times that tells us a whole lot of stuff. We're going to talk a little bit more about that as we flip the paper over. But any questions right now? All right, flip it over. Okay, so we looked at a graph, figured out end behavior from a graph because it's looking right at us and pointing, and we can figure that out. What about when we just have an equation? So for polynomials, because again, we're going to do this with more than just polynomials, but for polynomials, it's easiest, which is a matter of opinion, but I agree with it, to find the end behavior of the right side first. I'm going to show you why. Okay. So if the right side, okay, meaning we're heading to infinity, if the right side goes to infinity, then the leading coefficient is positive. If the right side goes to negative infinity, the leading coefficient is negative. Okay, so the right-hand side tells me if the leading coefficient is positive or negative, which way is it pointing. Then the left side, so after we figure out the right, if the left side goes in the same direction as the right, then the degree is even. If the left side goes in the opposite direction, then the degree is odd. Okay? The key to a lot of things in life, and especially in math, is consistency. So if you always check the right side first and then check the left side, everything will make a lot more sense to you. Also, somebody asked me as we went through this, because as we write the limit statements, I was writing the negative infinity first, then the positive infinity. And she said, does it always have to be that way? And I said, no, I always do it that way, maybe because somebody drilled it in my head. And I think it's like the proper way, but it's not necessarily wrong if you have them opposite. But again, I think it's better for you to be consistent because then you don't confuse yourself. Because sometimes we confuse ourselves, right? Let's be honest. I know I'm my own worst enemy. I don't know about y'all, but all right. We good so far? Okay. So then let's look at this. If I have a positive leading coefficient, then the right side goes to infinity, right? Positive leading coefficient, even degree, the left side is the same. That's what the ends look like. So then from that, I can write my limit statements. And I can say the limit as x approaches negative infinity, we'll just call this f of x because we don't really even have a graph, of f of x is equal to infinity because it's pointing up. As x approaches negative infinity, then we're going to positive infinity. Then the right-hand side, the limit as x approaches positive infinity of f of x is equal to positive infinity as well. Okay. So once you get the arrows drawn, the rest should be cake at this point, right? Anybody have any questions about writing the limit statements? Are we all doing this correctly? Maybe we should check our neighbor here in a minute. All right, so now if I have a negative leading coefficient, right-hand side goes to negative infinity. Negative leading coefficient, even degree, left side is the same. Do you understand how I'm coming up with those? Okay. Then let's write our limit statements. The limit as x approaches negative infinity of f of x, what's that going to equal? Negative infinity. And then the limit as x approaches infinity of f of x, that's equal to what? Negative infinity. Okay. Any questions at all? All right. So now back over here, we're back to a positive leading coefficient. Right-hand side is going to infinity. Odd degree. Left-hand side is opposite. That's what the ends would look like. So then write your limit statements. I bet you could do it without me. You can check yourself with me. Oops, I wrote the wrong thing. Okay. As we approach negative infinity, it's infinity. As we approach infinity, I'm sorry, it's negative infinity. I wrote it, I just didn't, sorry. As we approach negative infinity, it's negative infinity. As we approach infinity, it's infinity. I wrote the wrong thing first, and then my negative sign looks weird. A lot of infinities. Any questions? All right. So then here we've got, oh, I scrolled too much. Negative leading coefficient. So the right side goes to negative infinity. Odd degree, right-hand side is opposite. That's what that looks like. Okay. So write out your limit statements and then check them with me. You're right. It is opposite of the one on the left. That's a good way to look at it. Any questions at all? Now show your paper to one of your neighbors. Make sure everybody's paper gets seen by somebody and check your limit notations. See if you have any critiques about how they're writing it. Everybody needs to be checked by somebody. Just make sure that the form is right. Okay? So I'll show each other. We agree? Okay. All right. Are we good? Any questions at all? All right. So let's look here. It says determine the end behavior for the following polynomials. Describe the degree of the leading coefficient. We're going to do this part with our arrows. We're not going to write it out. Bless you. So if I look at this and I want to figure out the right side first, is the right side going to infinity or negative infinity? Infinity, because that's a positive leading coefficient. Is the left side, which way is it going? Negative infinity, because the degree is odd, so it is opposite. Okay, that makes sense? You see how to get that from an equation? Yep. Now that we have the arrows, we don't need the equation anymore. We can write our limit statements and get, for the L and the R is left and right. So the limit as x approaches negative infinity of f of x equals, what is that one going to equal? Negative infinity, because we just drew ourselves a little picture, right? And the limit as x approaches infinity of f of x equals what? Infinity. Good. Any questions? We good? All right. For B, what is the right-hand side? Which way is it going? It's not going left. Left is not a choice. Okay, it's going to infinity. Where's the left side going? The same way. Good. All right. Write out your statements. I know you're writing it a ton today, but that's to kind of also get it drilled in your brain on how to write it correctly. Oh no. What did I? The right-hand side is going to positive infinity. Yeah. Okay, so and let me clarify what I said a minute ago. Here, it totally matters where I put the infinity and negative infinity because they're labeled left and right. If they weren't labeled and I just had to write them both and I wrote this one first, it wouldn't be wrong as long as it wasn't labeled. You with me on that? But again, I think it's just better to be consistent and do left and then do right. Bless you. Yes, because left you're going to negative infinity, right you're going to positive infinity. That's which way we're going. That's the direction. So where x is going, yes. That is your left and right. Now you know your left and right. All right. Now, C, right-hand side, where is it going? Negative infinity. Left side is going negative infinity. Okay. All right, write them out. And then I want to talk about these a little bit. Limits. Yeah, so this as x approaches negative infinity, that's the direction we're going to negative infinity. It says x gets smaller and smaller and smaller. This shows you what's happened with y. Okay, any questions on those? Now let's talk about what we're writing. So listen for just a second. Listen carefully. Not only is it important, like if this is P of X, I have to call it P of X. I can't call it F of X or then I'm wrong because we're not even talking about F of X, right? Your other option, instead of writing P of X, you could write this. However, you are always highly encouraged to put the name of it because just like if I put F instead of P, I'd be wrong. If you rewrote this and you like left off the negative or something, then you'd be wrong. Does that make sense? So it's just easier to use the name, but you can see it both ways. Like you could have it where the whole function is right there, but it's way easier. And most of what we're going to do, just use the name. And notice when we're writing in a sentence and I can call things F or G or whatever, that's all fine. But here I have to actually have the whole P of X or F of X or whatever it is. Okay? Questions about any of that? All right. So D, E, and F, we're not going to write all that out for all of them. Let's just talk about our arrows. Okay? On D, right-hand side, which way is it going? Which way is the right-hand side going?
Down. Right.
Left, diagonal. All right, this is my leading term, right? Is my leading term positive or negative? Negative. The right side goes down. Not stupid. Left side is going where? The other side, yes. Whatever. Everybody okay with that? Everybody understand why? Because y'all all wanted that to go to infinity. Well, this is because of the sign. This is because of the degree. Yes, okay. All right. What do we think on E, right-hand side? Down. Because this is my leading term. Left is going up. All right. F is tricky. Wait, is it what? Ask me a question. Okay, when you form your question, let me know. Right, you got it? No? You got your question though? No? Okay. All right, F, right-hand side. Infinity or negative infinity? Okay, but on has to do with the left side. The right side has to do with the leading coefficient being positive or negative. Okay, check this out. 2x times x is 2x squared times a negative x is negative 2x cubed. So the right side goes to negative infinity. The left side goes where? Up. Exactly. Okay. We good on that? Okay, good. There you go. Any other questions? Even though he never asked you, but got answered. Yes. Yes. Okay. So when you have to multiply it out, we don't have to multiply it out. I need to think I'm going to take 2x times x to get my leading term, right? That gives me 2x squared. I'm also going to have to multiply it by this negative x. So my leading term would be negative 2x cubed, which makes and because of that negative right there. Okay. Yeah, you don't have to. Like I don't have to multiply. Oh yeah. All the highest degrees. Yes. Yes. But to find the degree, if you have multiple little factors, then you take the highest degree in each one and multiply them together. Okay, we good? Yeah. All right. Now, let's look at this. This says write limit statements. Now, listen. Usually if you were supposed to write a statement, doesn't that sound like you're supposed to use words, right? But your limit statement is the notation we've been doing, all right? So we don't have to write words. I mean, you have to write LIM. And I know you don't have a lot of room down here, so instead of stacking them, you can do them left and right. I mean, you can put them next to each other. So while I pass out the assignment, I want you to draw your arrows, write your limit statements for both of them, and then we'll check them. I'll come back up here and write them, and we can check them.
Okay, this one is up and then it goes down to the bottom. Right.
Like,
See, look at this one.
All right, so when you're done, check yourself with me. Let me know if you have any questions. Make sure I'm right.